All right, so welcome to Chapter 4, Threads. Quick disclaimer for you guys. This is actually the first video I'm shooting in the green screen room here at Polytech. I just wanted to put that out there for you guys. So I know you've probably seen videos from the other chapters, like Chapter 2, Chapter 3, or even the stuff on C. This is actually, even though it's not in sequence, it's kind of my first time here. So I figured I would practice here and then go back and shoot the other stuff. So just a little bit of a disclaimer. All right, so let's get going. So let's go ahead and start with kind of the overview material for this section. In the last chapter, we looked at the idea of processes, right? This idea that I have basically a program that's running, and this program that's running, right, well, hopefully I can have many of them at the same time, right? My system isn't very useful if I'm limited to just one program running, at any given moment, right? I would like to have, this application open, and this application open, and this application open, right? And when we first started exploring that, we had the idea of a process, which is an entire kind of program running in your system memory. We also have kind of a lighter idea, which is the idea of a thread. So threads, basically they're not standalone programs. Something like a process, right, is a whole program, right? You can picture in memory that process has, space for, for variables, for data, right, for program code, for, the stack, maybe has, backups of stuff from the registry, right? Has all sorts of info in memory, right? It's a standalone program. That's fine, right? And that gives us what we want, right? The ability to run things in parallel. The concern is that processes are a little bit heavyweight, right? There's a lot of stuff there behind the scenes. So what we can actually introduce is this idea of a thread. A thread is kind of a lightweight program, right? Instead of it being kind of this, monolithic thing that has all these resources assigned to it, a thread is going to be associated with or live with, right, a process, right? A process is this overall thing, and a thread is kind of this little just thread of control, right, that's in that same program, right? So it doesn't have its own, memory allocations for the program code or for variables or whatever, right? Instead, it's going to reuse all that stuff that a process has already requested. Instead, what a thread is going to keep track of is kind of flow of control, right? So it's another kind of place in your program that's running and doing stuff, right? Your program is running, it's running lines and lines and lines and lines, right? That's what the main process is doing. Threads all of a sudden have kind of the ability to do the same thing, right? They're running, going through lines, right? And they're kind of piggybacking on top of that process that's already there in order to do their own stuff, right? The key kind of difference here, right, is that the thread only exists, right, or is in the context of a process, right? A thread doesn't own everything, right? A thread doesn't have something like program code associated with it. It has to piggyback off of the stuff that the process has already requested, right? So it's kind of this mini thing, right? They're lightweight. As you can maybe imagine, it's a lot easier, right, for a system to, create a thread or destroy a thread than it is for it to do that for a process, right? Because again, they're lighter weight. So if you want, you can look at the diagram kind of on the right-hand side, and you'll see kind of this distinction between processes and threads, right? Up top, we have a process, which basically has everything reserved to itself, and it's just kind of one flow of control, right? It executing line after line, and then on the right, and then on the bottom, right, we have our three different processes, right? And notice they're all living in the terms of the same program, right? Same program data. The only thing that the threads get kind of to themselves is information about the stack, right? Because if I have these three different kind of lines in my program that are being executed, right? You picture functions, calling functions, calling functions. Well, for each of those threads, I am going to need to keep track of where it is in the program, right? So I'm going to actually need to have to maintain some sort of a stack, right, to keep track of which functions I've called which functions, what parameters are being passed along, right? So in order to kind of maintain that, right, that flow of control that each thread has, and it's going to be independent, I need to have, a stack for each of them. So that's kind of the key distinction. In general, when we have kind of this situation going on where we have a process with different threads inside of it, we'll say that is a multi-threaded process, which is probably a term you've heard before. So then at the bottom of the slides, I kind of have some benefits, right? What I would suggest, right, is that you maybe think about these on your own for a little bit and see if you can kind of interpret them and see, what does it mean, right? I know the book has a description, but think a little bit just from these terms. So ones on here, right, are, for example, responsiveness. Responsiveness, well, let's think for a second about our web browser. I think about, you're probably using, Firefox or Chrome or Safari, right, to watch this video. Well, in that kind of browser, right, you have different pages that are open. And sometimes there's issues, right, where you are browsing, all of a sudden a web page hangs or something like that, right? Well, in the old days when you had maybe a single threaded process, that was it, right? Your program was stuck, you couldn't do any work. Well, these days, right, you think about something like Chrome. Chrome has a thread for each of those tabs. So even if one freezes up, you can go jump to another one. And it's a different kind of program that's running, right? So you can go and do other stuff at the same time instead of having that whole program, right, that whole web browser, freeze out and is no longer any good. So that's an example, right, of using a thread, right, to give this kind of responsiveness, right, or also recoverability, right? Maybe that web page crashes, I need to exit out, and hopefully, right, it's by itself, it's running in its own thread, and so I don't have to mess with anything else, right? I can just, say, okay, go away, right? Let me open up a new web page, new thread, right, and go do something else. It doesn't bring down everything at once. So threads are very useful there. Another thing is resource sharing. So you can maybe think of systems, right, that don't have a lot of resources available, and so maybe your overall process has managed to grab some stuff, right? Maybe it has a bunch of memory allocated to it. Maybe it has a couple I/O devices it knows about, and basically, right, you can say, oh, these resources that have already been claimed, I can pass those along, right, to the threads, right? So the threads don't have to worry about all this kind of management stuff. I can just share those resources with whichever threads actually do need it. Another kind of advantage here, the book is calling this economy. This goes back to the idea, right, that threads are lightweight, right? They take up a lot less resources, right, a lot less time to set up, to destroy than a process, right? So they're cheaper to use. Last thing here is scalability, right? And this is something we're not going to talk about a lot in this kind of chapter, right, or this section. But what's important, right, is to say, okay, hey, there are some problems that are very large, right? Maybe you picture you have an algorithm that's trying to sort a data set that has billions and billions of entries. And normally on a single threaded process, that would take, say, days or something like that. Well, if I have different processes, maybe running on different physical CPUs, well, then I can think about maybe taking that big piece of work that I need to do, splitting it into pieces, doing it in parallel, right, and then kind of combining it and getting my result back out, right? So in a sense, I'm increasing my scalability, right? As I add more CPU cores, it takes me less time to compute my result, right? Therefore, I can compute larger results. So I have better scalability there. So this is kind of another key benefit to writing this multi-threaded application, right? Is we can kind of do things faster, we can do more things even.